Word O. Okay, and if I can go back to my, oh, I can't find it. I've got too many tabs. I wanted to say welcome in Japanese again. Oh, I can't find it. Anyway, so we are very lucky to have Rajat speaking with us again. A deeper dive was slightly different canyons, perhaps, in IoT. So I'd say take it away, and you can screen share, and we will be doing a raffle at the end for another one of our lovely mugs.
Sure. Thank you, Brian. Are you guys able to see my screen?
Yep.
Awesome. Awesome. Yeah. So, hey, everyone. Glad to be back here, as Brian mentioned, to speak on another IoT topic. So, I am Rajat Mathur. I'm a senior solutions architect with Amazon Web Services. And I've been working with Amazon Web Services for 6+ years now. And through these years, again, as a part of my solutions architect role, I have worked with a multiple enterprises firm, and while understanding their business requirement and transforming it to sort of some technical implementations to help them with certain business outcomes. So glad to be here. So during my last chat, right, like we discussed about the IoT core technology, and we deep dive sort of into the core components that really helps customers today to connect billion of devices and exchange trillions of messages. But today I am here to talk a bit more about the security aspects of IoT application, right? So and there are always multiple aspects to it. So let's see what all are the security dimensions that are provided by AWS IoT for us. So quickly going over the agenda, I will begin to talk briefly about the shared responsibility model that AWS has available for its customers and for folks like us to understand the security responsibilities. Then I'll be talking about different mechanisms and ways provided by IoT core service to think about securing your devices and end users that are communicating with the IoT platform. And after that, I will talk about AWS IoT Device Defender service. That is another fully managed service that is provided by AWS IoT to help you, run some security configuration across the fleet of devices that you have connected. So, any questions so far? Do you guys want anything else to be covered as well as a part of this conversation? So happy to alter based on any feedback here.
Chris Planky, I know you had wanted you had mentioned some topics, so feel free to jump in with your wants.
Yeah, no, these topics here do hit on a couple of the things I've been interested in. I've been really working on trying to build out some IoT solutions and think about how you go from a prototype all the way to production. So sometimes when you have these devices on hand for some of the initial beta units, you can obviously configure them very easily. But thinking about when you don't have these units on hand and when they need to connect to the internet for the first time, how does a user do that? Like things like mobile app pairing and things like that. Those are definitely some of the other areas I'm interested in, but what we have here and what we just said we would be reviewing sounds very interested, and I'm excited to hear about it.
Definitely, Chris. And I think during the end of the session, within Q&A, we can definitely touch upon some of the specific topics that you would like to talk more about. Definitely, it will be good to share my perspective on how to achieve, some of those IoT-based use cases. I think Brian also talked about them briefly over LinkedIn. So yeah, we can always talk more about it.
Awesome, exciting stuff. I appreciate you being flexible here.
Awesome. Yeah. So as many of you may know, while you are working on AWS technologies, that like we have this concept of shared responsibility model that really talks about these two distinct layer, one being the customer layer, other being the infrastructure layer or the AWS layer, where we are distinguishing the responsibilities that define security in the cloud. And those goes along the security configuration and the services that we are making available for our customers to consume and act upon to ensure that the data that you are being providing to AWS infrastructure is like secured end to end. And then there is like this another AWS layer or infrastructure layer, what we call, right, which always talks about security of the cloud. So AWS here takes full responsibility of anything that covers as a part of their infrastructure, let it be AWS global infrastructure or some of the foundational services construct that we are making available to you. So being it compute, storage, databases, networking, we are providing the right set of resources available to you in terms of the security configuration that allow you to incorporate a multi-layered security approach per your IoT use cases or any general AWS use cases in general, right? So just wanted to bring it out there that, whenever we think about security of any workload that we are planning to spin up of a public cloud technology like AWS, we should always think about the shared responsibility as to where we need to think upon the security controls that are needed to be incorporated versus what are the security construct that I can expect from AWS to provide me as a part of their backend infrastructure. So any IoT solutions generally have multiple players involved, right? And what we call those things are things like Internet of Things. So we are allowing user space, different devices and technologies to connect with each other through IoT platform, and at the same time, exchange these messages that can be consumed by application for future processing or whatnot. So these things are connected over internet, and these can be anything range from a microcontroller based device, a user that is trying to log in through a mobile application, web application, or these can be device sensors that are part of a factory fleet of devices and whatnot. So we really want to understand what type of security credentials these clients or users required when they are communicating with AWS IoT platform. So security with AWS IoT in itself is definitely a multiple layered approach. When we talk about security, we can talk about multiple aspects ranging from data security principles to authentication layer to authorization layer, right? So beginning to talk about the data security construct, by default within AWS IoT, all the data is by default encrypted both at rest and in transit. So when I say that, I mean that any data that your end devices or your web applications or your mobile applications are communicating to AWS IoT, all those data are by default encrypted at rest by using AWS owned keys. So you don't have control over keys, or you cannot use your own custom keys to encrypt that data per se, but AWS definitely provides you a way to have those data encrypted by AWS IoT itself. And the data is also, so the data in transit is also encrypted using TSL layer. So we recommend to any device or any application that is communicating with AWS IoT, we recommend you to use TLS 1.2 implementation or later, because that's where we are establishing that mutual authentication and security scenario, and we are using the same TLS layer to encrypt the data that is being transmit between AWS services or between users to these AWS IoT platform. Now, uh, we are talking about data security. So let's also talk about the multiple authentication mechanisms that we have available, right? So whenever we think about authentication, we should also always think about ways that allows your client or end devices to authenticate themselves to AWS IoT. At the same time, we should also have ways that are defined that allows AWS IoT servers to authenticate themselves. So AWS IoT really provides you a great mechanism to entrust that mutual authentication requirement by providing you ways to implement both server side authentication and client side authentication. So I mean, server side authentication is pretty simple. That happens through, again, TLS implementation. So you can imagine like a scenario where you are talking to HTTP HTTPS based URL over web browser. So what all like encryption happens there, the same sort of server based authentication happens with AWS IoT Core as well. So as a part of the security credentials, AWS IoT provides the root CA that you can present as a part of your request to AWS IoT, and then AWS IoT service authenticates those X509 certificate chain to prove itself that it is a actual IoT based server and not some random server impersonating to be a authenticated IoT identity basically. And now, like once the server authentication is being taken place, what you can see on screen are multiple client authentication mechanisms available with AWS IoT. So depending on the type of communication protocol you choose to incorporate into your use case. Again, the supported protocols today with AWS IoT are HTTP, MQTT over WebSocket. So again, depending on the choice of communication protocol, you can either use AWS IAM credential. Basically, you can use those security credentials to sign your request while making a HTTP communication to AWS IoT, or you can use X509 certificates as well as a part of your HTTPS communication. Now, if you have a requirement where you want to establish your communication as a part of your MQTT based implementation, then you can always use these X509 client certificates, and that those certificates can be used to authenticate your client to AWS IoT server. Now, often there are requirements where not only your end devices are communicating with AWS IoT, but you also have requirements where I think, as Chris mentioned, that we always want to have some sort of a web application or mobile application that we want to interact with these devices through AWS IoT platform. So you can always do that. So the basis that forms as authentication there is through its integration with Amazon Cognito. So whenever you have a use case where your users want to communicate with AWS IoT via like web application or mobile application, then you can use Amazon Cognito identities to implement some sort of a token based authentication between your users and AWS IoT client. And again, within Amazon Cognito itself, there are multiple ways you can do it. I mean, if you choose to use a combination of username and password, you can either go with Amazon Cognito user pools, or if you have a requirement where your users are authenticating through some federated identities like Amazon login, Facebook login, Google login, then you can use Amazon Cognito identity federation to achieve those sort of authentication use cases with AWS IoT. Any questions here? So apart from this traditionally available client authentication mechanisms for your end user and devices, AWS recently started to provide a separate authentication mechanism known as custom authentication that really allows you to build in some flexibility for your IoT applications. So if you have any use case, or if you are working on any existing IoT use case that is utilizing any other technology than AWS, and you figure out a requirement to migrate that existing IoT setup to AWS IoT, right? Then under those scenarios, you would never want to reprovision your devices, reprovision your web application. However, you would want to use your own ways of custom authentication. Maybe there is a beer token authentication mechanism that is already in place, and you want to continuously use that while migrating your setup to AWS IoT. So with the help of the custom authentication option with AWS IoT, you can simply use a Lambda-based custom authorizer, and you can write your own authentication flow within that Lambda authorizer to achieve your authentication requirement regardless of the communication protocol you are choosing. So the custom authentication mechanism works with all the three protocols, whether it be MQTT over WebSockets, or HTTP protocol. So yeah, apart from this traditional three available authentication option, we also have this another authentication option available that can help you achieve that flexibility in terms of migrating any existing IoT workload. Now, diving deep a little bit into it, like, so X509 certificates provide AWS IoT with an ability to authenticate clients, right? And essentially maintain a mutually authenticated device-based communication. So AWS IoT not just support X509 certificates that are generated within IoT itself, but we really provide you the flexibility to either have a mechanism to create and upload these certificates by directly interacting with AWS IoT platform, or there are other mechanisms available. Like if you have a scenario where you have a client certificate on your devices that is generated through a certificate authority that is registered with AWS IoT. So if you have those sort of a requirement, you can still allow your devices to communicate with AWS IoT, but during that time, you will have to first register the certificate authority with AWS IoT, just to give them an impression that the certificate authority used to generate your client device is something that AWS IoT recognize. So as a part of the device onboarding, you can always connect your end devices that are using client certificates during the first connection basis, if that certificate authority is already registered with AWS IoT. Now, if you have client certificate that are generated or that are derived from certificate authority that are not currently registered with AWS IoT, then you can still connect those end devices with AWS IoT. But again, you will have to make sure that any communication that happens between your client devices to AWS IoT, the certificate authority needs to be authenticated with AWS IoT first before initiating that communication. So as a part of this X509 certificate package, there are three components to it, right? So the first being the certificate itself that allows you to allows your device to present that certificate as a part of the authentication mechanism, and then IoT server matches it against the certificate authority that it has like registered with it. Now private key helps as a second form of authentication here. So once the certificate that is presented by the clients are being validated, then AWS IoT server would ask you to present the private key that comes along as a package to the security credentials. So once that private key is being presented by these devices to AWS IoT, after that only any communication will be made successful to our AWS IoT message broker. And the third component to it is the root certificate authority. Root certificate authority helps to authenticate IoT server itself. So while the first two constructs are helping you to authenticate your client, the third construct that is coming as a part of your X509 certificate chain is really helping you to validate that the server that you are communicating with is the actual IoT server, and not a random server that is impersonating to be an authenticated IoT server. So these root certificate authority keys, private keys, and certificates, again, as I mentioned, are something that we provide as a part of IoT platform. But it needs not to be the case all the time. So if there are requirements where you want to use your own certificate chains derived from your own certificate authority, the only thing that you should be careful about is to register your certificate authority with AWS IoT first, so that whenever a client now initiates a connection to communicate with AWS IoT, the connections go successful while the IoT server is checking on the authenticity of the certificate authority used. I'll take a quick pause here just to understand if there are any questions, because within these two slides, I went over literally multiple aspects to client authentication mechanism. So
I'll say I'm really happy to see the Lambda authorizer as an option. I'm used to using that for, API gateways, so it seems like a very natural way to do things.
yeah, no, that's absolutely correct. So yeah, initially, I mean, the authentication options that were available really tied to the type of communication protocol you choose, right? But yeah, with custom authentication and Lambda-based authorizers, it really provides you a no-brainer flexibility to use your own custom authentication for any type of communication you are doing with AWS IoT. Awesome. So now while I'm talking about IoT permissions, right? So AWS IoT also provides you a way to assign, fine grained permissions to these devices and users, specifically by using IoT based policies. So these IoT policies are similar to IAM policies. I'm sure like many of you have already dealt with IAM policies. So IAM IoT policies are pretty similar to IAM policies. It's just that the principal construct or the principal dimension for that IoT policies are a little bit different. So in IoT world, you may use IoT policy to maybe assign it to a X509 cert, or maybe assign it to authenticated cognito identity. So anytime you create or you write your own IoT policy, so there are only two principles available in IoT world for you to assign these fine grained permissions to. So depending again on the authentication mechanism, you can either use IoT core policies and attach it with the specific client certificate that you are using with your devices, just to provide them the level set of permission on what that particular device can do while integrating with AWS IoT resources, right? And at the same time, now if you are using cognito identities for your web-based or browser-based application, you can use IoT policies and associate those IoT policies to those authenticated cognito identities to achieve same level of fine-grained controlness there as well. Again, while talking about policies, just wanted to mention there. So within AWS IoT, there isn't any limit around how many number of policies and certificates you can create, right? Because we recommend you to maintain that uniqueness in credentials that are going to your devices, right? So imagine a scenario where you are wanting to connect 10,000 of these distinct devices to AWS IoT platform. So we recommend you to not only generate but associate each unique certificates to these devices. So we do not recommend you to reuse the identity or reuse the security credentials between multiple devices. So we recommend you to maintain that uniqueness. And while maintaining that uniqueness, we are also requesting you to maintain that a principle of least privileges while assigning those permissions through IoT policies. So, this is just a sample IoT policy example that is presented here. As I mentioned, as a part of the IoT policy, they are pretty much similar to IAM policies. You can simply specify the API call or the actions that you want to allow your particular principal to follow, right? So in this case, there are two statements that are allowing your principal, again, a certificate or a cognito identity, to publish and subscribe onto a specific resource, right? And resource being here is a MQTT topic where you are basically publishing or subscribing those messages and allowing your end devices to consume as and when required. And otherwise, the policy is straightforward because it very well aligns with IAM policy principles. So just sharing the best practices out there, as I mentioned. So for each device, I recommend you to make sure that you are assigning these unique certificates or private keys to all of those. And then if you are using IoT policies and associating with your certificate, just make sure that you are not providing any overtly permissive policies to those principles, and just to make sure that we are following the principle of least privilege here. So apart from using X509 certificates for client authentication requirement, AWS IoT also provides you an option to use these IAM user and group credentials, right? So as I mentioned, like if you have a requirement where you want to set up a IoT application while communicating to IoT platform or publishing through a HTTPS protocol, then you can simply use IAM-based credentials, security access key, and access key ID as a part of your SIGWI for signing process. And now, if you are using AWS SDKs or CLIs to run some of these API calls like publishing or subscribing, then the SDKs already have like pre-built options available for you to have a secured credential file that is encrypted, and you can use that encrypted credential file to essentially establish that communication with AWS IoT server. And while using these IAM user and group-based security credentials for client authentication, IAM roles are also used within AWS IoT. So not many people knows it, but when you have a IoT application use case where you want your IoT platform or your IoT setup to interact with any other backend AWS services, then you will need to go and create an IAM role that is basically assumed by AWS IoT service on your behalf. And based on all the permission that has been granted through that role and the associated IAM policy, IoT core then communicates to these backend services, right? Like it can be AWS Lambda, it can be Amazon SNS service, or any backend service that you want your IoT application to interact with. So by default, AWS IoT core does not have any default permissions to make that communication on your behalf, because you are solely the account owner, and you are the one that owns the entire data and the flow for your IoT application. You really need to go and create that distinct and separate IAM role that can be then assumed by IoT core policy, so IoT core component to run that communication behind the scenes on your behalf. Any questions there in terms of making a distinction between IAM user policies and IAM role policies? So, I mean, I think we briefly talked about it. So now again, let's talk about like use cases where you have these end users communicating via mobile and web applications, right? So in such scenarios, as I mentioned, depending on the level of granularity you want to achieve, you can use our Amazon Cognito service for achieving both federation, and if you have a requirement where you want to maintain those, user credentials in app itself. So what you see on the screen is a simple depiction on how you can enable your users to authenticate themselves through Cognito workflow. So if you have a user base that is like signing up using a custom authentication flow that has been set up using Cognito user pool identities, then you can within your app itself, your user can request those access ID tokens and like to return from Cognito user pool identities. And once those tokens are returned, then you can use those tokens to make another call to Cognito federated identities. That is basically allowing your users to federate their identities, to sort of use any pre-existing sign-in authentication using any of the federated identities, like I mentioned, Amazon, Google, or Facebook. So while doing some in-app coding itself, you can simply make call to these Amazon Cognito API calls to establish that flow between both user pool identities and like identity pool identities there. So giving a quick summary out there of different client authentication mechanisms available for you to allow your devices to be secured enough. We talked about X509 certificates, and you are using IoT policies with it. For rules engine component, where you are integrating with other AWS services, you can use and assume IAM role and its associated policies to grant that least privilege policies to IoT core, so that they can make these backend API calls on your behalf. For your web application and browser-based application requirement, you can use federated users and identities by integrating with Amazon Cognito service. And if you have an existing situation where you want to use any authentication mechanism of your choice, regardless of the communication protocol you onboard to, you can always use Lambda function-based custom authorizers and associate an IoT policy to it to allow that fine-grained access control within your identities as well. So We already talked about the pre-baked client authentication options available, and these options are essentially used when you are planning to provision your device, when you are planning to onboard your device to your any new or an area of migrating your existing IoT application. However, IoT also lets you, define these custom authorizers to achieve those things. But users and customers also came up with some feedback where they wanted to see what ways AWS IoT provides to continuously monitor those fleet of devices that are connected and that are communicating with AWS IoT platform. So that's where I think in back in 2018, AWS IoT launched its new service known as Device Defender. That is a fully managed IoT security service that enables you to build some guardrails around the fleet of devices that you are connecting with your IoT platform. And not just like defining those guardrails, but it really provides you more intelligent ways to audit the configuration, create alert based out of any anomalies that are detected, or maybe alert based on its integration with Amazon SNS, and also allows you intelligent way to mitigate any of the anomalies that are detected through Device Defender. So talking about its first feature, uh, auditing capability with Device Defender, helps you to ensure that your connected devices stay secure, right? So at any given point in time, if you have a requirement where you have these multiple thousands of devices connected, and you want an intelligent way to group those devices into distinct device type, but at the same time you want to ensure that you have right alerts in place to identify deviations of these pre-configured devices from security best practices. There may be requirements where you want to identify any devices that is using an expired client certificate, right? If you want to identify devices that have IoT policies that are not least privilege policies, but they are very overly permissive policies. So all those checks can be bring in place by setting up right audits to either your entire fleet of devices or the subset of devices as you choose to create from, right? And the way these audit check works is that you can create a one-time audit check based on like any specific thing that you are planning to detect anomaly around. But if you have a requirement where you want a continuous automated process to basically scan your fleet of devices and identify any deviation, then you can create these audit based on a schedule, right? You can create it like once a week, twice a week, once in a month, and things like that. So while creating these audit checks, it is really providing you an automated way to run some predefined check against the fleet of devices that you are including as a part of this audit check.
He's Indian.
Yeah,
Gauti.
Sorry, did anybody had any question?
No, just someone wasn't on mute. I got it.
Okay. Awesome. So while defining audits, just wanted to go over some of the audit checks that are available today. So when you are creating an audit within IoT Device Defender, you get to choose among the predefined checks that are available as a part of the fully managed service offering. So these audit checks can go into multiple dimensions that can allow you to ensure that your device are authenticated, that allows you to ensure that the right authorized permissions are given to these devices and application. And if there are any deviations across the setup logging mechanism, it will also alert you based on that, based on those requirements. So whatever is mentioned on the screen are some of the predefined checks that are available today as a part of AWS IoT Device Defender offering that you can use to ensure that your cloud-based device configuration are being following security best practices that is recommended by IoT service itself.
I have a question.
Yeah, sure. Go ahead.
So Rajat, nice presentation. You mentioned that the Defender can govern the devices, which is really nice. I have a question about the resources on the AWS cloud and how
Yes.
are those governed? For example, with EC2 or instances, we could check that the EBS volumes are encrypted, as a simple audit. Give me a sense of what type of checks would there be that we would be responsible for when we create IoT resources on the cloud?
Yes. So, I mean, so by default, Device Defender is not activated for you, right? So it is presented you as a service. So if you want an automated mechanism to basically monitor the security of the fleet of devices that are connected, then what I mentioned on the last screen, these are some predefined checks that are available that you, while creating an audit, maybe after the presentation, I can show you as a part of the demo too, on how to go and actually enable these checks as a part of your scheduled audit. So while creating an audit, you can simply select these predefined check, like are these device certificates shared, what is the quality, when the device certificates are expiring, and in the backend, AWS IoT is maintaining everything for your specific AWS account, right? So these check, what they do is they simply go and check those configuration, and they validate the backend configuration with the configuration that is available on your devices, right? And when I say on your devices, it can be your physical device, or it can be the cloud representation of your device, right? Like within AWS IoT, how we recommend you to create a thing analogous to your physical device, right? And then you have these construct of certificates, keys, and root CAs associated to your thing. So that's how you monitor. But if you ask me what is a recommended approach, then the recommend approach is definitely to at least have checks in place to understand the security credentials that are associated with your devices. First being uniqueness of those credentials, and second being like if those credentials are unique to these devices and they are not shared across like multiple devices. Does that answer your question?
Yes, it does. Thank you very much. And it's a very nice service, this Defender. You mentioned that the IoT service actually can, it has like a rules engine.
Yes.
And is there any sort of like best practices for securing those resources that I may add to the cloud in the rules engine? Kind of like like EBS volume should be encrypted. Is there anything like that for the rules engine?
Yeah, so I mean, as a part of your rules engine, right? So rules engine, I think I mentioned it in my last presentation, but it is essentially a data processing component of IoT core platform, right? So a rules engine component is the component where all the magic happens. So once the data lands up into AWS IoT, you want to make some meaning out of the data, right? So now then with the help of rules engine, you integrate it with other AWS services. So within rules engine itself, you have to assume a IAM role that basically grants IoT service permissions on your behalf to make those API calls to backend services. So that is the level of security that we are providing in the rules engine component there, right? And then the encryption at transit and in at rest is already in place. So now once the encrypted request goes to your backend AWS resource, then the responsibility falls onto that particular AWS service, right? So let's say your rules engine component is sending a payload to Amazon S3, right? So then we will ask you or recommend you to think about encrypting the data with some sort of Amazon S3 provided like data encryption options, right? where you can use your own custom keys with Amazon KMS, or you can use S3 keys, like server-side encryption keys that are provided by Amazon S3 and whatnot. So we are recommending you to still share security responsibility between these each service resources that you are creating as a part of your entire IoT application flow, if that makes sense.
Yes, it does. And it's very nice that you guys have encryption on by default. I think that avoids some misconfigurations, missteps. So I think it's very smart. And it's a very good point that, that rules engine may interact with other services, and those services have a lot of configuration choices that are the user's responsibility. So thank you.
No problem. Yeah. So, rules detect feature with like Device Defender allows you to create now distinct security profiles for all the fleet devices or subset of your like devices, and that allows you to outline the default behavior that you expect out of those devices, right? So when you go and create a rule detect resource, you simply go there, you create a security profile. You can mention anything like I don't expect my client or my connected devices through to throw authorization error for more than twice in a row, right? And once you like create those security profile, and once you mention those threshold, then this rules engine can basically act upon the corresponding CloudWatch metric and generate some alerts out of it. So while configuring the rules detect feature, you can act upon the associated cloud side and device side CloudWatch metrics, and you can generate some alert based out of that. Now, one thing to note with rules detect feature is that you have to create your own static threshold while creating these rules to detect any anomalies, right? So that is one thing that is different with rules detect versus using audit behavior, because audit behaviors allow you to run these pre-provided checks onto devices. But with rules detect, you have an additional capability to define the default behavior of devices, and these default behavior of devices can go across multiple dimensions. It can go across authentication, it can go across authorization, it can go across network bandwidth, connect, disconnect. It can be anything and everything based on how you have configured your cloud side of IoT things. So once you define a rule, and once you define a security profile, you can simply go and enable those rule detect based on, and if there are any anomalies generated, you can create an alert mechanism by integrating with Amazon SNS. You can publish the message onto a SNS topic to further mitigate or to take action upon it as and when required. Or you can also generate an alert based out of CloudWatch metric alarm system as well. Right. So, when the service was launched, we came up with this rules detect feature. But I think not too long ago, Device Defender came up with this new feature, which is known as ML detect. So previously, while creating the anomaly detection, right, by identifying the device's behavior anomalies with some standard configuration, with ML detect feature, you can simply go and basically create alert based of some deviation that are powered by backend machine learning models. So while creating a ML detect feature with Device Defender, you can simply go and you can select the predefined anomalies and the corresponding ML models and the confidence rating, basically based on what the ML models think about that particular deviation. So you can simply go select those predefined checks just to make your system more intelligent. So rather than you being providing some static default configuration, you are allowing your system to to understand and pick up those standardization while interacting with your devices. So that's how ML detect feature is more advanced in its ways, where it is using machine learning models to make some more accurate decisions rather than you providing some standard default device configuration for your fleet of devices or the subset of devices that you have made connected with AWS IoT. And this all will make more sense when after this I will go to the IoT console and show you all those construct. And for all the features that I'm mentioning here, while it is allowing you to create that multi-layered security approach, you can simply go and choose your own configuration by your own choice on your own subset of device and create this multi-layer security solution for your entire IoT application.
If I can jump in with a question, I know Amazon some time ago created, I think it's called Device Farm, that will let you test mobile devices. And I'm wondering if there's been any thought to having IoT Farm, because I might want to test, my end of the system against, 1,000 simulated devices and so on. And I don't know that there is such a service, but there's always time. Reinvent isn't for 2 weeks. Y'all can spin up a new service.
Yeah, no. So there is an existing service known as AWS Device Tester.
Oh, really?
Yeah, that allows you to simulate, a EC2 based on the device, physical device configuration that you are looking forward on connecting to an IoT application.
Okay, awesome. There you go. Yeah. Thank you.
I can share more about it, but yeah, the idea is you can make any of your internet, so only that your device should be able to connect to internet. If you have that capability with your device, you can always use AWS IoT SDKs to make your device more intelligent and like to connect to AWS IoT in no time, because those SDKs come up with predefined like code that allows you to just put in like security credential, provide the IoT endpoint, mention whether you want to publish, subscribe, connect, or whatever API call you want to ensure, and boom, you go there. Like based on the type of programming language you select, you can simply configure your device to do that. But I understand your question. You want to not just ensure the connectivity piece, you want to make sure that your device configuration is withstanding when we are talking about thousands of devices. Awesome. Yeah, so some of the device defender metrics that the ML detect and rule detect act upon are mentioned here. Again, these are some of the metrics that are that are currently supported while creating that anomaly detection mechanism with device defender. So, I mean, if there are requirements you to monitor cloud side IoT resources, you can think about configuring a detect based mechanism on authorization failures, disconnect, message size, message received, or source IP, right? And one more thing, that why it is important to monitor these, right? When we are talking about IoT application, right, we are talking about, again, millions of devices. We are talking about some robust application that is continuously speaking to these devices. So you really want to ensure that there are no sort of impersonation happening. There are no sort of DDoS attacks happening. There are no sort of device configuration failure happening, right? And I will talk about more in my coming slide. But these CloudWatch metrics allows you to monitor those security failure scenarios while using some sort of a machine learning model based implementation that Device Defender provides, and act upon that data more intelligently and more proactively rather than reactively. So as I was mentioning, like with the help of auditing and detect feature, while you are making yourself aware of any anomalies that are going around your authentication setup, authorization setup, or any misconfigured IoT resource, you can always create alert to get notified about those, right? And this is as straightforward and as simple as with any other AWS services, that you can either simply integrate your existing output to a direct integration with Amazon SNS, where you are publishing that particular payload onto SNS topic. And based on the destination communication protocol, you can either consume that information over email, over message, or maybe send it to AWS Lambda for further processing, or maybe to do something more intelligent based on the findings that you are identifying with the anomaly behavior while using these alerts, right? And if not Amazon SNS, you can always create alarms and alert on your CloudWatch metric itself. So all the metrics that were shown there are some of the device side and cloud side metrics that AWS IoT Core publishes to Amazon CloudWatch on your behalf. So all those metrics are by default available to you in the CloudWatch console. You can simply go there, set up your threshold, and create an alarm based off Amazon SNS as and when required. Now, as I was mentioning, right, we talked about mechanisms that allows you to proactively understand anomalies, deviation from standard security best practices, but that is not just helpful, right? You also want ways where not only you are alerted when those security deviations are there, but you also want an intelligent way to mitigate those issues. So with this mitigate issues feature within Device Defender, AWS IoT allows you to mitigate some of those security configuration right on the top in a straightforward manner, right? So some of the mitigations are inbuilt, are pre-built, that allows you to fix some of the security configuration, like enabling IoT logging, replacing the default IoT policy, updating device certificate if they are close to expiration, and whatnot. So you can simply go mitigate issue, you can select the metric or the findings that you want to mitigate, and based on the pre-built actions that are available to you, you can try to fix most of the things. And some of the things that are not available, like maybe you want to change a device side configuration based on the findings that you are getting. Maybe you want to update firmware or software on your devices, right? So if there are no pre-built action directly available within mitigate issues, you can always integrate your device defender setup with either IoT device management service that allows you to send OTA updates, like over the, like on the air updates to your devices to make some of those firmware updates. Or it can also allows you to send your messages and publishing it to an SNS topic, right? And once it comes to SNS topic, you can always build some more custom logic implementation using Lambda or any other AWS service of your choice. So this mitigate issue feature within Device Defender really allows you to act upon the findings and fix some of those security deviation on the fly. Now, talking more about it, these are like some of the common security breaches that we are seeing across IoT-based application, some being intellectual property theft, data filtration, impersonation, I mentioned about this, cloud infrastructure abuse. So what you see on the red are the CloudWatch metric, IoT CloudWatch metric that you can audit upon to identify those security deviations. So let's say if you have a use case where you want to identify if any of your data was exfiltrated, then you can simply act upon the CloudWatch metric that is made available to you based on the message size. So you can go there, you can set a threshold on what are the standard device message configuration look like. You can create alerts on the top of it, or maybe you can create more custom mitigation issues while sending that information to Amazon SNS and acting upon it while doing some backend API calls within Lambda function itself. And some of the device side metrics that you can monitor to understand and monitors these physical devices that you have connected with IoT goes around DDoS attacks, surveillance, cryptocurrency mining, ransomware. So we are seeing use cases where like people are attacking these devices and making them less available for IoT interactions. So all the metrics, CloudWatch metrics that is available in red can be acted upon and consumed by creating these audits and MLT tags on AWS IoT Device Defender itself. Yep. So that was all that I wanted to cover today in terms of multiple security approaches and mechanisms that are available to you to ensure that your IoT application is secured end to end. There is always more to it. I think somebody asked me that what happens when the payload or the message goes to some backend AWS services, right? So again, we were just just talking about AWS IoT, but there are always these security mechanisms and configuration that falls upon customer responsibility, and then we provide you the security mechanisms while ensuring that each and every component of your entire IoT application is secured to the level of security that your use case required or your business requires. Yeah. So thank you for listening to me and being patient. I can just take a pause and maybe welcome any questions that you may have.
So Rajat, thanks for this interesting thing. You mentioned about the OTA. That's all very interesting. I guess how much of automation as a service can you do with all this? You mentioned Defender, you mentioned OTA, you mentioned rule engines. How much of automation can you do when you want to provision infrastructure and all that kind of stuff?
So there are a lot of options available. What I was talking about is definitely a small pie to the entire cake, right? So with AWS IoT platform itself, we have 7+ distinct services available that allows you to be an expert in a particular area. So we were talking about the security aspect of IoT application, but like with the help of all the services available, I can definitely name few. You can build like a automated fashion secured end-to-end IoT application using AWS IoT services. So we have AWS IoT events, we have AWS IoT Greengrass that allows you to bring compute onto edge. So if there you have requirements where you are talking about these end user devices that are not connected to internet all the times, and you want to run some compute local onto those devices and configuration, so you can use our end user software like Greengrass and build some logic on the top of it before interacting with AWS IoT. And this is just like the control and connectivity plane that we are talking about. Then there is a conversation about running analytics on the top of the data that has been gathered through AWS IoT, right? So we have services like AWS IoT Analytics. You can integrate with other services like Kinesis for real-time streaming requirement. You can send it to DynamoDB, you can send it to Lambda, Elasticsearch. So I mean, with the current integration with a different backend AWS services, you can possibly achieve anything and everything with AWS IoT platform, I believe.
No, what I was talking about was the CDK, right? Kind of an automation to provision these kinds of things. The Defender, the rules, yeah, I mean.
So yeah, I mean, all the features and services that are launched as a part of IoT platform are currently supported as a construct for CloudFormation and CDK.
Okay.
There could be some things which might be new, and there might be some back and forth in terms of, like, if something launched like 10 days back, there might be a disparity that they won't have a property in CloudFormation to utilize there. But ideally, I mean, I should say not always, we typically do a good job of adding CloudFormation support and CDK support while launching a particular service feature.
So where are these things persisted, like all these rules, and you're talking about these rules, right? Are they persisted in some database? Because then, it becomes, the implementation's responsibility to manage that database, to backup, restore, or disaster recovery for all that stuff. So what is the persistence mechanism for all these defenders and the rules engines? And
Yeah, so IoT core is not storing any of your data without your permissions, right? So IoT core itself does not have a mechanism by default to store uh, these large, like, chunks of data that you are gathering from these devices. So it is up to you that once the data lands in IoT to a MQTT topic, what do you want to do next? If you have a requirement where you want to manage it through object-based storage, you can send that data or stream that data through rules engine to Amazon S3. If you want to maintain with DynamoDB, if there are so like value name pair requirements, you can use DynamoDB. So I mean, you are the owner of your data essentially, right? So you have to manage it and you have full control on how you want to manage it. And again, depending on the type of service you choose, you can always put those security construct and configuration on the top of it to ensure that the data is secured.
Well, I'm not talking about the data coming from the devices. I'm talking about these other peripheral things, right? These defenders, right? It is storing where your over-the-air updates are, or where your binaries are, what state the device is in, the rule engines. If I construct a rule for the messages, I mean, it has to be stored somewhere, right? I mean, where is it getting persisted, right? Who manages that?
So it is, I think it is part of the backend IoT infrastructure, I should say. And they do not reveal on how they are managing in the backend, but I'm pretty sure that they are using one or the other AWS services behind the scenes. At the same time, security never get compromised, right? So we ensure that all the security constructs are in place. So as I mentioned, like IoT does a good job of encrypting your data both at rest and in transit. So I mean, wherever the data is persisted in the backend, it has been completely managed and handled by IoT platform, and it has been like managed on your behalf. All those IoT resource configuration, I should say.
Okay.
Yeah, and it is part of the fully managed and scalable service. So if you have thousands of MQTT topics that you are using today, you can go up to 10,000 of MQTT topics that you will be using today within your AWS account. Everything is managed and scaled on your behalf behind the scenes.
Okay, great. Thank you.
Thank you. I think I have a question on chat. Does it work outside of Cognito Auth? Can you elaborate a little bit on that question?
Huz, can you say more?
Wait,
Yes. So I mean, if you have a requirement, where you want to maintain user management or you want to federate it with third-party identities, then only you need to use Amazon Cognito, right? But as I mentioned, if you have a requirement where you want to use a custom authentication flow, maybe an authentication flow that you have currently implemented or an authentication flow of your choice, you can use a Lambda-based custom authorizer, regardless of the type of communication protocol you choose. So yeah, you don't have to choose Amazon Cognito all the time. It really depends whether you want to use it or not. But if you don't want to use it, if you don't have a requirement to manage those security construct like user database through user pool or federate to third party services like Facebook, Amazon, then you can use your own custom authentication.
So I'd love to do our raffle, and we can see if there are more questions after that. Rajat, did you come up with a raffle question?
I have a question, but I can participate too, but I don't have an answer that I'm not sure. So if many people are going to reinvent, what will be the most talk technology at reinvent this year? What do we think?
Well, we don't, that's sort of a tough one for the raffle. But okay, anybody want to jump in on that? Cyber security automation. Interesting. So, okay, as always, I have a sci-fi related raffle question, and right now we're raffling off one of our new sustainability. That's interesting too. One of our new Blast and AWS mugs, and if the winner is outside the US, I will try like heck to get it to you. And so the way our raffles work is you type the answer in the chat, and first one to get the right answer wins. And I've tried to make my questions reasonable, but some people think I'm just crazy sci-fi nerd. So we'll give it a go. So in the Amazon series, The Expanse, What was the name of the ship whose explosion started the war in the first episode? And I'll give people a hint. It generated the phrase, remember the... Okay, we're getting nobody winning. Okay, can anyone name any one of the characters from The Expanse?
Somebody mentioned.
Remember, put it in the chat. Okay. Planky, you got a question that might be easier by chance?
How many stars does Brian's Alexa skill have on the Alexa marketplace?
Oh, Clarissa, Michael got it. Sorry? and
100,000.
unfortunately, my skill does not have as much stars as I would like because I'm not getting a lot of reviews, but Clarissa is a good answer. Michael, if you send me your, where do you live? Oh, easy, I can do that. Email me your address and I'll get a mug out to you. Yes, and if anyone wants to go to the Alexa Skills Store and give a review for Premier League, it would be appreciated. I'm certainly not allowed to ask for a good review, but if you Alexa, stop. Okay. Any other questions? We're a little bit past time.
I just want to say thank you for the presentation. Absolutely excellent. Loved the deep dive. And appreciate you coming back to visit us. But what service do you think is going to be the most talked about at reInvent? I wanted to hear your answer on that one.
I think like AI and ML should be one, and sustainability should be another topic.
Ooh, interesting.
But yeah,
Sustainability.
machine learning is growing, right? And it touches upon many other technologies as well. So I think it will be interesting to see what they are bringing onto the table this year with reInvent.
Right. I'll mention that I'm going to be on a panel giving an instant reaction to Werner Vogel's keynote in the developer lounge, like half an hour after the keynote. So we can rejoin there. But again, thank you so much for the talk. Thanks, thanks everybody. Have a great rest of this month as we get into this crazy time, although all times have been crazy in the last couple of years. Fill out our survey if you would, and we will see you on the flip side of reInvent if we don't see you at reInvent. So thanks, everybody.
Thank you, everyone.
Thanks, everyone.
Thank you.